Now, when I do this for the YouTube, if I take yours, I'll try this out and see. I'll make sure that I splice it, I split it, so that 4.3 now goes on to section 4.3, and we're not, you don't have to kind of hunt and peck to find out where that stuff is. Okay, we have been talking around about this information for quite a while. So again, I don't really think this is going to be a real stretch. It's not going to be a whole lot of new information for us. We've got another good theorem here, and it's the test for increasing and decreasing functions. Let the function be continuous and differentiable. Are you getting used to that? That's kind of the usual thing here, continuous, continuity, and differentiability. If the first derivative is positive, then the function is increasing. First derivative is positive, the function is increasing. Is that a surprise to you? If the first derivative is positive, then that means that the tangent line is an increasing line, which would mean that the function would have to be increasing at that point. Okay, so it doesn't, I don't think we were surprised at that. If the function, if the derivative is negative, is it a surprise that the function is decreasing? If the function is 0, it says it's constant. In other words, it's neither increasing nor decreasing. We know from what we've been looking at that that means then that that has an extrema. Okay, so this work really is not that new to us. We've been kind of working around through it for quite a while. Find the critical numbers. Now, critical numbers are values of what? Input or output? Critical numbers. Input values or output values? If I say find the critical numbers, are you finding input values of the function or output values? It's input, absolutely. These are input values. So find input values that are critical. Now, if they're critical values, critical numbers, input values, what makes them critical? If they're critical numbers, it implies that the first derivative is what? Is 0 or undefined, yes. If they're critical numbers of the function, that means that their first derivative at those values, its input values, the derivative is undefined or 0. Okay, find open intervals in which the function is increasing or decreasing and locate all relative extrema. Okay, so the first thing we need to do is determine what? Yeah, I can tell we're kind of slowing down a little bit here. Yeah, find the derivative. So the derivative of this function, what rule do you have to use? How about product rule? Okay, we got a factor times a factor, so we're going to take the first factor times, do I still expect you to do this line of intent? Yes, I do. It's the only way I have of determining or seeing whether or not you are remembering those basic rules. Okay, so find the derivative. So the derivative would be x minus 1. What's the derivative of e to the x? E to the x, okay. Plus e to the x times the derivative of x minus 1. Just 1, okay. I can factor out an e to the x, and I have x minus 1 plus 1, or simply e to the x times x. If I want to find critical numbers, what do I do with the first derivative? Okay, so set it equal to 0. So I have 0 equals e to the x times x. One of those factors has a value of 0. Can e to the x be 0? What exponent on a constant or on a base creates a 0 value? Impossible. Okay, so we can't do that. Or x is equal to 0, well, that's a possibility. Okay, so the input can be 0. So what is a critical number of the function? Okay. Find open intervals on which the function is increasing or decreasing. Okay. Now, this would be a whole lot easier if all we did was graph the function. Could you tell by looking at the function if it's increasing? We did that on the first day of chapter 4. We can tell. Okay. But analytically, how do we go about finding it? Well, we know that something, we don't know what, something happens at x equals 0. So we can say this could be an extrema. Okay? This could be, I'll write that so you can read it maybe. This could be an extrema, meaning it could be a maximum or a minimum. We're going to set up what's called a sign chart. By dividing the number line into as many subsets as needed about the critical number. So if I look at a number line and I place 0 here, I've got numbers less than 0 and I've got numbers greater than 0. So what we're going to do is to look then at intervals. And we've got inputs that are less than 0, and we have inputs that are greater than 0. Now, I don't know. I know that at 0, something special happens. And I know that at 0, if this happens to be positive here, in other words, the first derivative is positive here, and the first derivative is negative here, then I would know that at 0, I had a relative maximum. If I know the first derivative is negative here, and the first derivative is positive here, then I know that I've got a relative minimum. If it's positive and positive, I really don't know much of anything. Okay? I just know that it's a critical number, and we have to take another look at something else to determine that. So we're going to take a test value of something in here, and I always, go for the easiest one I can. Maybe x equals -1 and x equals 1. And I'm going to find out what's the sign of the first derivative. That's all I need is a sign. If the first derivative is positive, the function's increasing. If the first derivative is negative, the function's decreasing. I just need the sign of it. So I'm going to go back to my derivative, which the derivative was e to the x times x. Right down here so I can remember it. And if I look at the first derivative of -1, I have e to the -1 times -1. Is the first derivative going to be a positive quantity or a negative quantity? Which is it? Negative. Yeah. So the first derivative is going to be negative. If that's the case, then my conclusion is that the function is increasing in that interval. Well, what's the sign of in this interval? Well, let's see. The first derivative of 1 would be e to the first times 1. The first derivative at 1, is it positive or negative? It's going to be positive, right? Positive quantity? Okay. So my conclusion is that the derivative is, whoops, I said positive, I made it negative, so we'll change that, positive, is increasing, and I see I made a mistake over here. Someone I saw was conferring with their neighbor on this. Does this look better? Okay. So in other words, if the first derivative is negative, we know that the function is decreasing. If the first derivative is positive, we know the function is increasing. Therefore, at x equaling 0, f of x has a relative minimum. Okay? That's the sign chart. We have an interval that we determine. We